You ask a question? No. About what now?
About my quiz.
Yeah, sure. Ask a question.
Mine is 9. That's a lot. All I didn't do is put the X in. That's hurtful.
Wait,
That's
that
a lot
is
of points.
kind of huge.
I know.
How many problems are on the total? They were each worth 12 or 13 points.
Well, I'm happy I got a couple.
Okay. So yeah, you lose a major chunk if you miss the major concept behind it.
Okay, let's stoke it up this way. I don't know how I did that right. I'm really excited about that.
What's that? What do you mean?
I don't know how I did this right.
Okay, just try to see why you thought it was wrong. And try
Oh
to
no, I was
reinforce.
just concerned that I didn't even do the integral. Like I forgot that I did.
Oh.
Yeah.
So
I
you
genuinely
did.
thought it was one of those times that I didn't even do like calculus.
Yeah.
Remember that
So
one test when I didn't
there
even
are a couple things I want to say in general. I haven't seen a lot of this, but this is very easy to creep in to things. There's a couple people that did this now, and I just want to kind of, to use an old phrase, nip it in the bud. This here, watch this. What is this? There it is.
Yeah.
Okay. Is this true?
No.
Shit, no. Yes? Hell no.
Oh yeah, no.
No way. Okay. So I just want to stop it right now because sometimes people are like, oh, this is cool. Anything on the bottom becomes ln. Fantastic. Of course not, right? What's the general rule that works for something? How would I write this so I could really see what to do with it? Yeah. So the general rule that applies here, the only time it doesn't apply is when the power is -1, right? I like it. So then this one is easy, of course, right? So it becomes add 1 divided by that, so that's just -1 out front. So you get -x and -1 plus c. Okay. So just want to cut that off right there. The other thing I still see happening is stuff like, give me something, Jeff. There's some. Look at that stuff. Okay, let's say I add this, which we currently aren't even able to do. And can somebody tell me what this person did?
Derivative top from the bottom. Basically L'Hopital stuff.
No, they didn't. No. They didn't do L'Hopital's. I appreciate that, though. That does sometimes happen. That's a more rare one.
Is it?
They integrate at the top and they integrate at the bottom as if they have nothing to do with each other, right?
Yeah.
Even differentiation of that would entail the quotient rule, which is not straightforward, correct? It's not hard, it's not straightforward. So integration of something like that should be even worse most of the time. Does that make sense? So really none of the rules of differentiation carry over. Again, it's always the idea that integration has to have an answer for weird differentiation rules that happened. Yes? Like U sub is the answer for chain rule. But integration does not have a chain rule. Does that make sense? Okay.
It gets confusing though.
It does?
Doesn't have a chain rule.
Really? Yes, it does. It totally does. I understand. And these are understandable mistakes to make. And I'm kind of happy if the integration was done correctly, even if overall that's incorrect. Yes? I still have a place I can find happiness. And I'm like, all right.
Not right?
No, it's not.
Why?
Because it isn't.
Oh.
Because, all right, so one thing is, the major thing you did,
Okay.
what is 1 plus tan squared u?
Secant squared u.
Beautiful. You didn't integrate that.
What do you mean?
You did not integrate. 1 plus tangent squared is secant squared. Did you integrate?
Oh.
Okay.
Wait.
I want this to make sense. So watch, guys.
No, that's just an identity, right?
So if I do this and I say, okay, the answer is this.
Okay.
No, right? No. Because that is this.
So
Have
that
you
would just
done
be-
this yet? This is still here. Get out of there, plus c.
Yeah.
I still haven't integrated. I just simplified the inside. Same thing there.
So then what would be the integral?
Well, so you did this.
Yeah.
This is still here, of course, because that is that.
Yeah.
So this is still here.
Yeah.
What's the integral of secant squared?
I'm spacing right now.
What's the derivative of tangent?
Secant.
Secant squared. So what's the integral of secant squared?
Oh, tangent. That's very good. Very exciting.
I would like to go over 6.2, number 52.
6.2.
I always just tend to find
52. Oh yeah. This one's kind of a beast. Who was I? I was talking to somebody about this problem. Yeah, this is like a week ignoring Thanksgiving, like a week ago. Okay, so the big thing with finding volumes of solids for us, there's two things. This is not a rotation of something, correct? How can you tell it's not a rotation of something? It's a freaking triangle. And if it was a rotation, you should be able to find cross sections that are circles. Yes? So this is not a rotation of something. But even within our rotation thing, what is it we're doing? We're adding up a bunch of circle, disk volumes. This area of the circle times the thickness. Yes? Is it you guys? So I'm adding up a bunch of that. So here, what's the repeated shape? It's not repeated, but if I put my origin at the bottom, as I move up to the top of the the pyramid, the cross sections are all triangles. Yes? So, let me see. What's the best way to draw this? Okay. Where am I? What you've got to do, Scheisse, if I do put the, the 0 here, right? Let's see, what's the best way? I'm trying to figure out the best way to draw this. What would be a good way to draw this without... All right, real quick. This is a lot like, but not perfectly the same as this problem. Yes? So I'm trying to figure out how can I draw. I'm really not a good artist. I don't know if you picked up on this. But if I just replace this with a triangular piece, you need to figure out for a cross-sectional part of it, for any arbitrary cross-sectional part of it, how does so the whole thing here was, how does where I am at the moment correspond to the area of that piece? So what they're trying to do here is they're trying to write the area as a function of where I am as I move along this shape. So you could even do exactly like they did and put the 0 at the top of the pyramid and move this way, yes? Because this is a solid, I can turn it around if I want to. Does that make any more sense? So your whole purpose for this becomes finding the area function based on where you are as you move along the height. As you move, well, in this case, move down from the top, if you want to do it that way. Does that make any more sense to get you going?
Yeah.
Okay.
I was confused. Like, I thought I had to rotate somehow, and I was like, well...
Gotcha. And I'm not saying that is going to be easy, necessarily, but at least you now know what to attack, right? Okay. Anything else? Emil, did I give you back your...
Yeah.
I did, okay.
Number 3.
Oh, I'm going to give you this stuff.
I did not get one.
Yeah, I didn't bring hard copies, but I think I emailed you guys a copy of it.
Right.
So where are we at?
Number 3 on the 6.
Oh, what did I...
Yeah.
problem with? Because there are a lot of different kinds of mistakes.
I'm not sure it's like that.
Oh. Well, I mean, even in your picture, you tell me there's one place that you... No,
kinda looks wrong. Yeah.
Oh, up here.
And in the picture,
I know, but so what? This could have come out of your calculator, I don't know.
there's no calculator on the phone.
You're a good point. But when you graph this, you still have to tell me, I wanna see algebraically these things coming up. So algebraically, where did you get,
I plugged it together and then I got this, and I see if you plug it together.
where did zero come from? Okay.
So how would I get zero from my calculator?
No. Alright, how did you get zero, period, is my question.
Because they all have an X in them.
Okay. So, how do you solve an equation like Maria? No. How do you solve an equation like this?
You make it easier.
What is the correct way to solve this equation?
You pull out an X from each side.
Say again?
Pull out an X from each side. And you have X equals 2. Or oh no, you subtract the 2X.
There we go. Because if you divide by x, you are losing an answer. Yes?
Yeah.
Never divide by a variable unless you are being very cognizant of what that means. So you lost the zero answer when you divided by x.
I don't think I did divide by that.
Does that make sense?
Yes, you did. Because you went from x squared equals 2x to
Oh,
x
I
equals
did.
2.
It's X equals
Yeah.
2. Okay. Alright.
Yeah.
Mine is hard.
Aw.
It looks like it should be, shouldn't it be 1/32?
Yeah, I totally could have made mistakes here. Which one?
4G?
4G?
Yeah, it should be 1/32 because you have to do 1/8 as well.
Oh, I see what I did. I was looking at the wrong. I love you, Jeff. You're awesome. Wait a minute. You need this to show up, right? Sorry?
Yeah.
And so this is almost that. It just needs a 4.
Multiply by the 4, but then right there where you go and take to that one.
Oh, of course. I forgot that. That's a good job, Jeff. Yeah, so here it should be 1/32. Okay. So right there in 4G, everybody, it should be 1/32 times this business.
You have to split it up.
Okay. I like it. I'm still averaging about a 97 on my answer keys. Maybe a 96 now, I don't know.
Which one is that?
4G. You know, the old school wireless thing. Yes?
On 5, A and B, that new expression you made, is the X supposed to be a T?
Where are we at? Sorry?
On 5A and B, is the X, like after like 0.1 and B, is that supposed to be a T?
No. Okay. Remember when we did F-Talk 1, where we defined a function like this? And then we had f of t inside, yes? Okay. In general, so this is like 7. You can change this. Is this supposed to have any real connection to this? What does this mean? What is this doing? You guys can do this. In the integral, what is t doing? What is t doing in that integral? Some guys are like, it's just freaking sitting there, dude. What values can it take? 0 to x. So if I made this the same variable as this, then that's not doing what it's supposed to be doing. It's just whatever x is. Does that make so? That to me, I was a little surprised. No, not a lot of people had more questions about that, because to me that's one of the weird little details. But this can't. How do I say this? When I drew this picture, since I identify a spot here as x, and I want to be able to go, so then I have to have another variable that goes from 0 up to that to define the area up to that. I can't have them be the same variable because they don't mean the same thing. So here, why did I specifically, so here you could say, well, why did you switch them? Because it said first t years. So I want to go from the beginning to t. And to be really, really honest, you can put whatever the shit variable you want here. As long as it ain't t. Because t's already got a job to do. Yes, maybe. That is weird. But there's no reason they have to be equal. In fact, that would make the whole thing go to shit if you did make them equal. Or the same variable, right? Hopeful.
Because we were talking about a function versus what you're going to.
Yeah, the weird thing, and again, this is, I almost don't blame you. Maybe you didn't want to ask because you're like, I don't want to. This is a very weird function. We have never seen a function like this ever before, not just because we had never talked about integration before. That function is a function of one variable. It is, right? But it's given, so that function, given some function f, it's the area up to some number x. It's the area under that. So it is only dependent on one number. But how do I draw this function? By plugging t's into it to see where the height goes. So there are two variables in it, but one of them doesn't matter for what I'm doing. F of t exists. G of x I'm creating using f of t. I don't know if I'm really, you guys, I love it. Some of you guys are like, that did nothing for me.
Sad this is going to be on the test.
What's up?
So I'm sad this is going to be on the test.
Okay. This particular problem is a really weird problem, but once you see it, you kind of go, hopefully you guys, once you see it, you're like, okay, that makes sense, maybe? No? So, this problem. I save this much every year. Let me see, where do I define this? Yeah. I save this much every year. Okay. So how am I going to figure out how much money I've saved after 5 years? Don't I have to add up all the savings? Yes. That function is continuous, yes? So just because it's in years doesn't mean I can't figure it out after 1/10 of a year, after 1/20th of a year, after 1/10000000th of a year, yes? Therefore, I'm not adding up discrete things. I'm adding up an infinite number of little things, yes? Because I can take every small little step.
So it's like n, like t is just like a representation of like n, basically, or like just n.
Well, I think you're trying to bring in Riemann sums, which is good, because that's basically what I'm trying to get at, which is why it becomes straight to integration. All right, so what is this again? Why does it look like this? Why does that symbol look like that? Anybody remember?
Sum.
Yeah, it's a freaking S. For sum, yes? So, if I have a problem where I want to add up stuff, so you could add up 7, 5, and 3. That's easy. Because they're discrete. Right? But I want you to add up every number between 0 and 1. Every number. Holy shit. I can't do that. I can't even get started. What's the first number after 0? What's the first number after 0? 0.000. It's like, yes, maybe you guys start to see what I'm saying? So integration is the answer to when I have an infinite number of things to add up. Not generally, but that is one answer to it, because we can't. All right. So I've got an amount of money I'm saving every year. So if I have a part of a year, I'm saving some part of money. So if I want to know after t years how much total money have I saved, I've got to add up from 0 to t all the savings I've accumulated. Maybe. Yes?
For the solution, when you did the 3,500 divided by 2,000, you did ln, right, to get rid of the e and bring the
Yeah.
down?
I got it.
And then you divided by 0.1.
There are a few of these problems I got bored at the end.
Okay.
And here I got so bored I even did it wrong at first. But yeah, I think I put 35 over 25 when I did.
And then divide by
So here, hopefully this makes sense. If I've got a, representation of the savings, and I want to know exactly when I'm going to get some level of savings. Kabam. Yes.
How would I solve every number between 0 and 1?
How would you solve what now?
Every number between 0 and 1.
Oh, how would you add those up?
Yeah.
Oh. That's Calc 2.
Oh.
Yeah. Here's another little teaser for Calc 2. Some of you guys are like, I'm okay with not knowing. Calc 2, you get into doing infinite sums of sequences, right? Okay. Now, obviously, well, maybe not. Well, I'm going to leave it there. I'm not going to try to teach you some Calc 2 right now. Not right before test.
Would it be useful?
Huh?
Would it be useful?
To answer that question, yes. For the next test, no.
Okay.
So I'm not going to do it. You can ask from the quiz, you can ask from the practice test, you can ask from homework. You can even just say, can you do an example of this? Right?
I have one more question on the quiz.
Okay.
There's just a question mark and a -1. I don't know what.
Every now and again, I'm like, let me just take a point out. Oh, I have no idea what's happening.
No.
I have zero idea what's happening. You need to put that together better. I can't, I see the right answer. I think it's the right answer. Is that a 4? Yes.
Yeah.
Okay. But I don't see what got you there.
Well,
So just kind of recollect that.
for practice.
Yes.
Okay.
So one thing I'm grading on, this doesn't really come up a lot, but if I cannot follow the logic, you're going to lose a point because one purpose of this is to have you communicate mathematics better.
Okay.
Yeah.
How is this right? I'm very confused.
Say again,
I'm
sorry.
seeing- So I know this one's wrong, obviously.
Okay, good.
But then I changed the balance
Good.
because we put
Good.
the,
Yeah, looks good so far.
okay, so.
One more step.
Okay, and then just actually, okay.
No. So, I mean, what part of that is easy to do? What's the natural log of 1?
0.
Yes.
Yeah, so
Okay,
it just makes
okay.
it another 6, which is great, but then. So that's the answer. Yes?
And you really don't need the answer back because 6 is already positive. But if you leave it at 5, because you're technically 5.
I, for the life of me, cannot,
For
I
the
tried this
life
for like
of me.
3 hours last night. I cannot get 2 and 3 on 6.1.
All right.
I don't understand it. I mean,
So
I'm going
one
to math
thing
class
maybe,
later for
are you
it,
trying,
but-
do you see how the first, all right, so there's a problem. What is it again? E to the x minus x e to the x squared?
Yeah, and I think it's from 0 to 1, I'm pretty sure. The graph.
Isn't
itself-
this completely easy?
Yes.
All right,
it's
so I
the
would break
second
this
part
up.
of the problem.
I would break this up like this.
Yes.
This is easy as shit. What function is, oh God, Jeff, zoom out. What function is stuck? What would you let u equal here? This is u substitution, right?
Yeah,
Because there's a function that's stuck.
x squared,
Yeah, so if u is x squared, what's du?
2x.
2x?
Oh, so you just added 2?
Okay. But sometimes, I didn't know if the issue was you forgot you could break that integral up.
Yeah.
So
but
your
then
u sub doesn't have to work for both parts because you could break the integration up.
all of the examples I found were like 2 e to the e. I was like,
I'm with
what's
you.
going on?
I'm
I
with you.
don't understand.
I'm working.
Okay. Are you gonna adopt this if we don't put dx after the du part?
What do you mean? Sorry. After the
So
du?
like
Oh,
technically it should be 2x dx, like technically.
if you do it probably more than once.
Okay, yeah. So
I will take some.
well, I don't
things
think
out.
you docked me on the quiz, but you kept like drawing.
Because
arrows.
that's, yeah,
Yeah.
that is huge. That's a differential. Without that piece, it doesn't make any sense.
Okay, so then I can do
Yes, it's good if I remember. Let me think. I think you got this backwards though. You need this in here. So if you put a 2 here, what has to go outside to balance it out? A 2, not a 1/2. So it should be a 2 out there, right? Because you need a 1/2 to show up inside. Yeah. That's the only thing, yeah. So if that was a 2, you'd be fine. Because I mean, 2 rad x, 1 over 2 rad x dx becomes du. And of course, this becomes just you there inside. Yeah, and then that's some easy stuff. And then you just throw what you was back in.
Or do you
Yeah.
just subtract
Great.
them and do the whole?
I think I know one, but I might be
You break it up.
why is there need to make
Add them, like you subtract
Oh,
them.
because, alright, any function, if it's just the derivative of an x squared. But what's the derivative of 3x minus 1
Actually, you-
when they have chain rule?
So this will be.
Right, so it was 3x minus 1 squared. That would be 2 times this, times the derivative on the inside, yes? So, is this function is a function of x, there it is. Is it just x? No. So whatever I get, I'm gonna multiply it by the derivative of the inside function.
Okay, so if it was x cubed, you'd do like 3x squared.
If it was x cubed, yeah, there would have been a 3x squared. Yeah.
Okay, so you take the derivative of the one on the top.
You take the derivative of the inside function. So again, let me see. So guys, for this. All right, for this, what's inside the g of x function here? Is it just an x? Is it more than just an x? All right, so for example, if I have this, what's inside the function? Is it just x? Careful, come on. What's inside the function? Isn't it x squared minus 2? Wouldn't this require a chain rule? So the inside function here is more than just x. Is the inside function here more than just x? No, it's freaking x right there, right? That is the inside of this function. That is the part that can change. So here, I wouldn't have to do chain rule if I took its derivative. Let me put it over here. So if I had this, what would this guy's derivative be? Right? Are you guys with me? This is straight up f talk 1. So what's the difference here then? What's the inside function here? What's the inside function here? 2x. So when I do a derivative, I'm going to get f of x, because that is the derivative rule for integration, times derivative of the inside function. I like it. So stay with me. Let me see if I can make this point. Did we learn a derivative rule for e to the x? Yes. Is it your favorite one? The correct answer is yes. Right? G prime is e to the x. Kick ass. The rule for e to the x function is its derivative is itself. So, what do I do if I have this? What's the rule for e to anything? It's itself. Yes, there's the rule for e to something is it's itself. And then what rule comes in and says I get a turn? Chain rule. So what's the rule for the derivative of an integral? It's the function evaluated at the variable endpoint. So I apply that rule. Of course I did this wrong. I love it, Jeff. Is that what some of you guys are looking at me? I'm so focused on that I forgot it. So it's the function evaluated at the variable endpoint. That's the derivative of an integral rule. And then chain rule says, hey, I get a turn now. Right? And just to remind you guys, chain rule applies here too. But the derivative of x is 1, so it doesn't show up. Just so you understand that chain rule doesn't turn on something. It's always there, but when does it show up? When the inside function is more than just x. Because otherwise it would just be a 1. So this is I need you to stop doing this.
Why?
Because you've got x's and u's. You don't want that. I know you.
I'm like showing where DU is. That's my point. Does that make sense?
Sort of, but you still have an interval here, right?
Yeah.
Okay.
Okay.
But you do sort of need to not mix these.
Okay.
Because you shouldn't let yourself feel comfortable ever seeing that.
Yeah.
Because the whole point is to get rid of all the extra. Now, on one level, I totally understand. You're sort of like, I'm just replacing part of it and I'm going to replace the rest of it next.
Yeah.
But you don't even want to let yourself do that.
Okay.
You want to make sure you got everything, then go right over to nothing but use.
Okay.
Okay. So that
Yeah.
sounds picky, but
Can you show me how to do a sentence?
yeah.
Thank you.
All right, everybody's knows the quiz. Oh, maybe we should do it up here. Damn it. I missed my board so much, but oh well. All right, somebody's got to record. I'm just going to do this piece. Right? Can you see it? All right. So somebody help me out. U would be what here? X squared. What's du? 2x dx. Now, I understand, and I appreciate if you're going to get help from a tutor or somebody, and they've got their own little ways to do shit. And there's nothing really wrong with those ways. Screw it, Jeff. My way's better. Here. It doesn't let you make as many mistakes as you could if you do the other. So what I don't do shit to this. And again, if you have somebody helping you, they show you divide by 2 and all that kind of crap, okay. But it leads to easy mistakes down the road. The way I look at this is, do I have this in here? No. I'm missing a 2. If I put a 2 here like I need, I got to balance it, right? The good old Indiana Jones thing. No, you take the gold statue away, you put the sand down, he didn't balance his equation correctly, boulder comes down. Okay. If you've never seen it, see the damn movie. All right. So now what is this? What is 2x dx? It is du. And what is e to the x squared? E to the u. Yes? So I built what I needed to have inside so I could do the substitution, right? So I built what I needed. I needed a 2, so I did it by balancing stuff out. Once I got everything I need, I should immediately be able to make everything in terms of u. Right? It's all about you. All right. And now, can't get easier than that, right? What's the integral of e to the u? E to the freaking u. See, and then of course, you never want to stop at u unless it started at u. This started with x's, so I better put back in what u do be.
So the other integral just stays the same then. The e to the x just stays the same.
Yeah, that first piece, yeah.
Yeah, okay.
It just kind of comes for the ride. There's that minus this, yes? Does that make sense? It would be that, and then there's a minus sign, right?
Yeah.
Minus this.
Okay.
Yeah. Because,
And then you do the whole integral together, right?
Say again?
So like we split them up. And then,
well, at the end, you just
yeah,
write
and
them
then you
next to
put
each
them
other.
together.
Don't forget your plus c.
But we're integrating 0
Oh,
to
0 to
right?
1? I didn't
Okay.
see that. So
Okay.
now put your 0 to 1 thing. Yeah, okay. And then throw that stuff in there. I like it. Yes.
1C on the quiz.
Oh yeah. What happened there? Let's see how much you can say about this without just giving it away. So that was this here, right? What was it from? So one big thing people made a mistake about, if I do this, what mistake have I made? Yeah, what is 2 and 3 all about? 2 and 3 is what, from 2 to 3 is what x is doing. The minute you got a different variable there, you really should change these. Now, I appreciate there's one person I think that put the parentheses around them. I'm obviously going to be okay with that because that's sort of like something I created for myself, right? Just got to be careful if you're going to take Calc 2. Some teachers really just don't like that. And I was trying to be really honest. If you do that, you're not going to be ready for some situations down the road where that can't be done. There are situations where you must change the limits. So it's a little bit better to get used to changing the limits Does that make? I try to make that point, but you know. So I don't know if that's part of the problem.
Yeah.
That was okay. So the minute you let u equal something, immediately figure out what u would be if you like x2, make x3. Yeah.
So since u would be x squared minus 3x.
Yeah.
du would be 2x, right?
Almost.
2x dx.
There it is.
So how would that play with the 4x up top? Because in order to make that, you have to have 1/2, correct?
Well,
You move it up to the other side, you move it to du, to do that
you
divide
have
by
2x in here, don't you? In fact, you have twice 2x, so you can just take a 2 out.
Sure.
And then that leaves you with exactly what you need. So it's not a situation where I have to put a 1/2 to make a 2. I've got too much shit in there, so I'm going to take some of it out. I don't have to make it show up. So normally you put a fraction in front or something that will cancel if you have to make something show up. This is a problem, the opposite problem. I got too much shit in there, so let me take some of it out of the way.
So then I would just completely take that out, and then it'd just be.
Yeah, so I would take a 2 out. Then I got 2x dx, I got my du, and then I'm going to have 1 over u. Yeah, okay. And of course, change those. Yeah, I like it, yes.
I multiplied by 1/2 at the 4 and then put the 2 out. That's
If you
the
put a
only thing.
1/2 here,
No.
what?
I put a 1/2 in front of the 4.
Okay,
And then
okay.
just took two-
All right,
yeah,
all
and
right,
just
sure.
balance it with the 2. That's the same thing, right?
Yeah, I like
Okay.
it. So that's another way to look at this. If you put a 1/2 here, you have to put a 2 here. Yes? That's fine. Me, I kind of think of it as 4x is 2 times 2x, and then I just take this 2 out.
Yeah.
Both
I
ways
didn't think
work.
of it that way. So
Both ways work. Yeah.
Is this right?
Oh, wait. Where's the rest of it?
What do you mean?
Minus 1 plus 1/2 is what?
Oh.
They don't cancel yet.
Yeah.
And
But
what
other
is
than
a
that, it's right?
what's a whole e minus half of the e?
1/2.
Yeah.
Okay. Okay, there we go. Got it.
Did you find another?
Yeah. That makes more sense.
Oh, I totally did.
Yeah, no, we're gonna go to that.
All right, good job, John. So on, this is the last one, right? Here we go. No, not the last one. Where'd it go? Which number is it? Oh, that's Jeff. You got 2 pages, dude. Oh, yeah. Yeah, number 7. I just forgot the negative here. So I'll grade myself. The nice thing is I've already passed these classes.
Oh,
What grade do you think you'd get if you were taking your own class?
If I was what?
What grade do you think you'd get if you were taking your own class?
Like I never learned calculus before, you said.
No, like if you're taking it now.
Well, it's like the first time, like you haven't been teaching.
Oh, I'd kick its ass. What are you talking about? I mean, if I wasn't allowed to remind myself of anything, just blindly gave me tests, it would still kick its ass.
Yeah, I mean,
What are
like
you
if
talking
you cloned yourself and then one of you made a test to give it to the other one.
So here's what I want you to understand.
This is a very strange type of.
Here's what I want you to understand. This is what you don't understand because you're in calculus right now, guys. If I gave you an elementary algebra test,
Oh. No, it would be bad.
it would be bad.
I'm horrible at factoring.
Oh, okay. Well, but overall,
Factor.
you would at least get a B.
Yeah, yeah.
If not, hopefully better, right?
No, people can ask me that.
Because why? Because it's used everywhere. Here's what you don't understand. Once you learn calculus, it's the same thing. Once you learn this, and you go a little bit further in anything, in science, in math, and whatever, you're like, how did I do shit before I knew integration? I mean, you don't even understand. So I don't think I've said this to you, but math starts at calculus. Everything before that is learning how to freaking breathe. And then here you're like, oh, let me move around now. I don't know. So I don't like to tell that to my Anybody who's not in calculus yet, that would be kind of evil. You're not even doing math yet. But that's just like ground level, here's your hand. And now you're doing, I can pick shit up with my, I don't know, does that make sense? Is that really important? No, it's not going to help you in the test, but calculus is one of the most fundamental, it is where math starts. It's insane, and you can't relate to that because you haven't done shit after this yet. You're in it. All right, that's enough of that. Anything else from anything? And this is why whenever I teach calculus, I feel extra pressure on myself because it is such a fundamental thing. So I'm not saying I put extra into it on top of whatever else, but it's just such a fundamental class. Anyway, I'll stop.
Are these right? So I can bring them in. I'm not gonna discuss that.
Oh,
Because you said you just have put X in, right?
well, okay, several things.
Okay. Several.
If you differentiate an antiderivative, shouldn't that be gone on the integral side?
But didn't we technically not
Okay.
integrate
Watch. What is the cube root of 11.72 cube?
11.72?
When did we cube root it? We haven't cube rooted it yet. Why did you say 11.72? Why isn't that still there?
Oh, because you just
Because these
canceled
kill each other. So the integral of shit, derivative, these kill each other.
that. Okay.
Yeah. But they kill each other in a prescribed way, right?
So, but I still keep the negative, right?
Of course.
Oh, okay.
Because it's there now, yeah.
Okay. But other
But
than
the
that,
other thing,
what?
what did you replace with X? All of the ones. What did you take? Is there still a T there for
Oh
some
my
reason?
God, why did I do that?
That's all right. I mean, I obviously
No, it's
made
okay, it was like the last one. I was like,
mistakes like
what?
that too.
I'm sorry.
It's easy mistake.
Okay.
There you go.
And then these are right though?
That was right. That was right.
That was it? Yay.
Okay.
9 points. For one step. That's so hurtful.
So yeah, you have the 8x cubed, and then you
The
take
one
2
step
out, and then you have the 4x.
Was the fundamental idea.
Is this where we're putting corrections?
I'm not even gonna
Thank you.
pretend like you know it.
Is this where we're putting corrections?
Yeah.
It's either
She's a whole sergeant in the Army. 21. What? I have done nothing with my life.
So many students of mine, I'm like, I feel they didn't do anything,
You
even
have a
though.
master's in physics. What do you mean you did it?
Well, compared to some people, yes, no.
For this one, where it's like, will we be given that?
Yes.
Do you teach math, or like how to?
I'm probably gonna teach it next academic year.
Okay. I wasn't planning on
Because
taking it.
full-timers, we make a schedule for the fall and the spring. So I'm teaching 180 again in the spring. So I like to kind of do Calc 1, fall spring, Calc 2, fall spring, Calc 3, fall spring. Does that make sense?
Yeah, okay. You do like
You
cycles.
should teach physics because there's only 2 physics classes next semester.
Did I tell you?
There's literally 2.
Did I tell you how that works? They offer me a course
Yeah.
after I got everything set.
Yeah.
Way after I've got everything set. I'm
Yeah.
like, I'm gonna drop something.
Yeah.
What course did they offer you?
Oh, no, I'm saying.
You take a 2, yeah. Yeah. Because if you take a 2 out, you're left with 4 Q, which is what you need. I like it.
I think I got everything. All I still
Yeah.
use on two. Is it literally like doesn't input an action into the equation as instead of doing it?
Yeah, so you turn it because the rule has to have the constant to x, and then the derivative, and it kind of makes sense it should be that easy, because the derivative should kill an integral, right?
Yeah.
But it kills it in a prescribed way. It's sort of like my point here with a cube root of cube, right? They kill each other.
Yeah.
Because antiderivative and derivative, they should kill each other. It should be easy. There's a couple things to be careful about. Because it's a derivative, so chain rule might come to play, but it still should be fundamentally easy. Because they're undoing each other.
Yeah.
Yeah.
I got it.
What course did they offer you? The one you
It was like, well, I've gotten offered several over a few semesters. And normally it's, well, one time I got like a 141 at times. But normally they offer me like, sort of the lowest level in degree. It's kind of like whatever's left over. So, higher stuff I know. Physics, I think it's physics 130.
No, that's physics.
Like the concept.
What is physics 100? It's like,
It's like the concepts of business. It's like that.
oh, it's not even that. The math is.
I'm pretty sure. I've taught that kind of course once. It drove me insane.
Yeah.
Because it's almost impossible to explain some physics concepts without the math,
Yeah.
which is basically what the whole class is all
It's
about.
basically just formulas, like memorizing formulas.
Well, not even that.
But
I mean, it's really actually harder. Even in algebra-based physics, I am either just go, here's the formula, just out of nowhere, there you go.
Yeah.
Calc-based, you're like, let's develop the formula. That makes a lot more sense.
Yeah.
Okay. So, I mean,
I still find it crazy hard anyway.
By the way, there are two of the rotation problems that I kind of put on here just to test your stamina. So there is such a thing as math stamina. Would you agree with me if you accept there's math stamina? This would be sort of a problem that deals with that, because how do you do this? You have to FOIL this. You guys with me? The most important part is setting it up. The rest of this is kind of busy work, yes? So I am going to be careful and not give you one that involves foiling a trinomial. That's just busy work bullshit. I kind of wanted to put it here just to see if you had some math stamina to kind of just do it. It's just a brute force thing you do, yes? And if I were you, do like I did. Well, don't do like I did, because to be really honest, I just put all this shit into Wolfram Alpha and said, dim it. But you could do this on another sheet of paper, you could do this on another sheet of paper, and then just put the results back in the integral. So you're not trying to do it all, because this is, if you do this, you lose stuff. Yeah, okay. But yeah, it is that gross. There's no real shortcut. That's why you would hope you could use shells. What's better about shells in this respect? Shells does not involve that squaring, right? 2 pi r h, there's no squaring involved. And anyway. So that's why personally I like shells better, but you can't always use shells. Damn.
So it's pi r squared and 2 pi r h, right?
Yeah, yeah. And then what they call washers is just the difference between two disks. So it's not even, to me, they shouldn't even give it a separate name. Yeah. So sometimes we use one disk, and sometimes we use two.
So this is
Haven't got there in the
homework
homework.
and the fifteen is H, right? And then this right here is S. And then right from there is
I
S.
can't finish 5.5, and I don't know why. Because no matter how many times I try, I can't get it right. I get like -4 nights. This answer is 3, and this answer is 2. What am I doing wrong?
What is that? Oh, that's a 3, right?
Yeah, yeah.
Okay.
So is that right, or am I, is my algebra wrong?
Equals X over X, right?
Yeah, is that say,
This-
that's 2 and that's 3, right?
Yeah.
Okay, so 2/3, that's right.
Okay.
The 2/3.
And then I changed it from 1 to 27 because I did 1. Well, no, because that's wrong.
Well,
It's not ln
Well,
of u to the 2/3.
U equals 1 plus 2x. So when x is 0, u is 1.
Uh-huh.
When x is 13, u is 27.
Yeah, yeah.
Okay.
So see how it's kind of like, I
But-
just did it a million times. So I was like,
Did you actually integrate?
This is H.
That's, so when I, it's erased because it was wrong.
Well,
But,
integrate now.
Okay, so then it would.
I would much rather have it written in the form this, because then that rule is easy.
Okay,
So what I'm saying is, you have this,
yeah.
right? What would that u2 done?
-2/3?
Yes, good. And then integrate that.
Oh, I was trying, wait.
So I didn't know, I wish I knew, I don't know if you actually integrated,
So
or.
it wouldn't, I tried to do ln of u to the 2/3.
That's exactly what I was talking about just a minute ago.
Okay,
right?
yeah, that's why I was
The
like,
only
that's wrong.
thing the integral becomes ln is if it's 1 over a first power of the variable.
Oh.
Right? That is the
Yeah.
only thing. Because
Okay.
this rule here,
Okay, yeah.
works for every value of n except -1, of course, and that's where natural log comes in and says I got
So,
it.
so negative
So
3
not a
halves.
damn other thing is natural log unless
1/3?
it's 1 over
Wait, hold on.
first power here.
And then this would be 3.
And what goes out front? 3? Okay.
Right. So 3, that would be 3 halves, right?
Yep. 3 halves, you do 1/3 from, what do we say, 1 to 27, which is nice because I can do the cube root of both of those, which is why they
9
gave us this.
divided by 2. Wait, this answer's 3. Oh, 18 divided by 2 is 9 to the 1/3. Wait,
What?
I'm stupid, hold on.
Do it
Trying to
step
do it
by
in my head.
step. Do it step by step.
Are we gonna be able to use a calculator with this?
Yes.
Math calculator.
Oh, that was the issue, was that I had wrote wrong.
Yeah. Because either. Oh, I see. I think part of it was missing the exit. Part of it was this. If you want to do this, I highly recommend that you do this what I did. You look at the little parentheses around 2 and 3, so you don't forget that's not the right number. The minute you write this, you are wrong, because U doesn't go from 2 to 3. Well, it doesn't make sense. X goes from 2 to 3. So the minute you write this interval, you're wrong. It's gotta be wrong. Because that's how you, but if you put little parentheses around it,
And I just happened to have set all of my answers were right. So 2 out of 6.
sorry?
Because I was like,
No, you did fine. You actually did
It's like you
fine
don't have to worry about the
from here to there, because you brought X back, so now X does go from 2 to 3. So you can put a 2 in there and a 3 in there. It's fine. Is that cool? This one. So, okay.
All right, let's do this. I want to do U sub problem 2 different ways. Did Jeff bring enough paper? No. Why would you, Jeff? Oh, yeah, you did. All right. Get out of here, bud. Get out of here, remote. Okay. Let me see. I want to do a semi-simple. Okay. Sure. I'll make it nice. Okay. 1 to 7. Okay, whatever. Let's do this 2 ways. How would I do this? U is x squared minus 1, so du is 2x dx. This is an exceptionally nice problem, right? I've got everything I need. I can't put a 1 and a 7 here, though, can I? Because I'm going to make this du. So this has got to be what u does. So one way to do this, and the preferred way, to be completely honest, is to change. So when x is 1, what is u? 0. Because these have to talk about what this does. And when x is 7, what's u? 48. I like it. Now, the other way to do this next step, since I showed you, is to do like young Jeff did. I put little parentheses that reminded me this is not what u does. But the reason it's eventually going to work is I would bring back, get out of there, Plussy. I would bring back x. And now these go in for x. Now please understand, when I plug a 7 in, what do I get in here? Which is freaking right there. So, I mean, both ways do the exact same work. Do you guys see that? That's why both ways work, because I'm just kind of changing the order of doing a couple things, which math is 7 plus 3. I want to do 3 plus 7. Who gives a shit, right? But this way is a little more preferred because there are situations in the future where you cannot change them back. You have to change them because there's multiple things that happen. In fact, just to throw this at you, there are triple integrals in the future. Well, if you're going to take Calc 3. If you're not going to take Calc 3, you will never see the beautiful thing that is triple integration.
What would you even need Calc 3 for? Yeah. Engineering or like?
Screw that make a list of things we would not have if Calc 3 did not exist.
Yeah.
Yeah.
No, like what career specific? Because I feel like it's a class you have to actively seek
Calc
out
3 is
for
definitely
anything.
getting up there where it's like almost pure math and
Okay.
stuff. But off the top of my head, engineering is a huge one.
Right.
I mean, depending on certain courses passed through engineering, you could and of course physics.
But not to be like a doctor, right? Not to be like a doctor or a vet or something.
No.
Okay.
Yeah. Triple integration stuff. Well, Calc 3 is not required, as far as I know, for most medical professions.
Okay.
Wow.
So if you're worried, if that's what you want to do.
Oh no, it's not.
You
I
might
mean, I
be
was
free
just
from
wondering
Calc 3.
if that's like something I have to like for most STEM. It's probably not
You're gonna do another half.
in it, right? Like in the biology. end.
Real quick. What kind of volumes can we handle? Rotated shit that really kind of becomes one-dimensional again, right? Or two-dimensional, with that. Or things that have kind of repeated shapes.
Mhm.
Does every volume look like that?
No.
Alright, Calc 3 comes in and says, we're going to allow there to be an x, y, and a z variable to define this three-dimensional objects. We're actually in 3D. That's what triple integrals would be for. And of course, there's double integrals before triple integrals.
Okay. Oh, and I have a question on the practice test.
Yeah.
For number 2.
It's just suck in the average.
Oh. Number 2?
Yeah.
What's up? Oh, this whole business. So just to remind you guys, I will give you these if I ask you this kind of question, yeah.
Okay.
Because to be really honest, I started doing this answer key and I left the second piece blank because I'm like, I gotta look that up later because I never make you memorize anything I don't personally have memorized myself. Now, there will be at least one situation where if you don't know your trig identities, you're not gonna be able to do it. More than likely 2 situations.
How complicated? Like multiple secant squared, or
Could be any of the shit I told you at the beginning of this class that you had to have memorized. Could be any of that. You guys remember what you have to have memorized?
The top portion.
Top part of that thing! Yeah. So you look at some of the freaky shit down here, you go, oh good, I only have to know this stuff. That's the way you should feel. Yes?
I didn't do the tetrahedron problem with calculus. Is that a problem?
The what now?
The tetrahedron problem?
Oh, not necessarily.
I just use.
I mean, that's the only thing that's kind of like a problem. We'll see.
That's what I'm looking at now.
okay.
Yeah.
Did you give us a sheet of paper?
Oh, God, okay. Well, maybe in like 10 minutes. I'll do like a double integral. Because you got to build to get up to the triple integral. Yeah.
Like a double wouldn't be that bad.
Make it a double. I like it. There's some dumb joke in there, but you need to make it a double.
Did you give us a sheet of paper with it?
I posted it up on Canvas. Where did I put it? Is it on Canvas?
It is on Canvas.
Okay, there's that green sheet. It's got like mostly green. And then there's a thick black line that says everything above this line you must know. So go on Canvas and get that thing. Get that thing. I know I keep asking this. Remind me again, how many of you guys are taking Calc 2? The first chapter of Calc 2 is going to be trig heavy. How many are still going to take Calc 2? Not like crazy heavy, but it's going to be in quite a few of the sections.
Is it gonna be like hyperbolic as well?
Yeah, that comes into play. I'm trying to remember now. Yes, that comes into play. So that's why the people that don't teach their students, some people skip that whole hyperbolic section entirely, which I think is really evil. Because it just needs to lay the groundwork, so it's kind of there. So when you get there and they say hyperbolic, you're not completely like, what the shit are you talking about? So yes, that does show up.
It's this thing, right?
Yeah. Yeah.
Oh, I shoot for the final day.
So again,
For the day of the final. If you show up here at 9, is that fine or do you need?
what do you mean?
On the. Nine to 5.
Okay.
So we just get there.
Well, hopefully you understand. So one thing is, my office hour schedule is gonna change for final exam, right?
Okay.
I'm gonna be in this room like always, probably about an hour. So I'm gonna put my schedule together and give it to you guys so you know exactly what I'm doing. But isn't our final the first day?
It's Monday.
That Monday?
Monday, yeah.
So you almost don't care about the rest of my office hours after that, because it'll be done.
Yeah, and what are we gonna do? Like, we have class on Wednesday and Friday, right? Or the Wednesday?
Next
after?
week, what's special about next week?
I'm not sure.
It's the last week of class.
Yeah.
Okay.
No more normal scheduled classes after that. The only thing you have the week after next week is finals. You don't go to class the normal time. You go to class for your final. That's all you got to worry about that week. So we're not going to have classes after our final.
So we
We're
just
done
plan
Monday.
that.
Yeah.
Okay.
The minute you take that final, 9:25, right?
Oh, okay.
So 11:25.
9:25 to.
It's on your syllabus and your homework sheet.
Well, and when are we gonna, like, see our scores from the final?
So normally I tell people, if you can't wait, just email me. Because it takes, sometimes it takes one day for WebAdvisor to update, and sometimes it takes longer. I don't know why. So if you're like, I want to know, just email me.
I turned in the chapter 1 and 2 homework, like, on the day of the test. Is that still somewhere in, like?
That is somewhere.
I know, I have
In the
so many
ether.
missing
So
sections.
I'm gonna try to figure out my priority of what needs to be graded, and a lot of that won't be graded. I'm pretty sure I told you that before.
Yeah.
I try to go back and grade the people that made the lower grades on the tests, because they obviously need more help. So you might get a bunch of stuff back. If you did okay on the test, you might get a bunch of homework back that's got nothing written on it. I never looked at it, and I'm just assuming it's good.
I remember your one promise is that I'll get it back sometime before.
Yeah. So anything I'm gonna want you to make corrections on, I'm gonna give back to you this week, because otherwise it's a little bit evil. Finals tomorrow. I need corrections on all this. That would be evil. Say again? Hell yeah. You can turn in section 1 or chapter 1 homework on the day of the finals.
I'm not gonna do that.
You can't. You can't. You will get more than 0 for it.
Okay.
Yes? Which isn't saying much. Basically, the later something is, the less points you get back. Yep. Oh yeah. Okay.
So would I have to get a different one for that one?
I'll have to bring. I've got several that I need to bring with me, because I don't even know if you know how to do this. It can do. It's a computer algebra system, meaning it can handle integrating x squared plus 2x, and it'll tell you what the answer is in terms of x. Yeah, boy. It'll factor things for you.
Do you have a TA again too? Is that what?
Yeah, so I'm gonna have to.
I need one.
Even if you say you don't know how to do it, I'm gonna have to assume you do, and I'm gonna have to give you a different calculator.
Yeah, I need one.
Well, not today. I'm gonna give it to you on the test day and on the final exam day. No. For one thing, these are in the wrong place, right? Because the top, what's on top is the line, so the line should be first. And the second thing is, when you FOIL this, you lost your plus 4. And so it would be x squared minus 4x plus 4 if you FOIL it, right? Yeah. Oh shit, well that would be, so this is the way I would do this. I would FOIL it out, well, turn this around, FOIL it out, get my like terms together, and you basically end up with this just this way. Yeah. Every other problem I assigned, you don't think, is it, most important thing now is just to get practice on everything.
Yeah. Like,
So if
I'd
you get
rather
stuck in the
understand
minutia of
it.
doing every single problem, you're not gonna make it.
Yeah, I'd rather understand it than
Yeah.
have my homework every one time.
You know, like I always say, I'll be like, what the shit is this? Finish this shit. And you're like, whatever.
Lie in my
I'm
brain.
doing what I can. I gotta do my job.
Literally cool.
Hey! Look away. And that's not yet. Get out. I should have been like, oh, you want to learn calculus?
What other classes are you teaching?
What time is it? It's like, wow. What class is next? They love this class.
Yeah, I guess.
Whatever it is.
I think it's geology.
Yeah.
Huh?
It says so on the thing, it's like a bunch of geology.
It's a geology class?
And geography.
Well, it could be geology, geography.
We're talking about weather on the.
Okay, so it's definitely geology.
Yeah.
Or meteorology. Meteorology.
That sounds awful.
With all of it.
It is a somethingology.
So you know when to use discs and washers versus shells with the function?
So, the most fundamental way to decide between the two. So remind me, guys. Let's see if everybody knows this. If I'm rotating around the x-axis or something parallel to the x-axis, discs would require integral d what? I'm rotating around the x-axis or something parallel to the x-axis. Discs would require integral d what? dx. So if you're rotating around the x-axis and you have a function in terms of y that you can't solve for y, I can't use discs. Do you see what I'm saying? That's why, okay, so I give you a problem. Jeff, just do it over here. All right. I desperately want to use my board. Now you need paper. Oh, I know. I got all kinds of paper. I did have, there it is, okay. I give you a problem to do, and let me see, how do I say this? I had it in mind, and then I had to find paper. So let's say I give you x equals a function of y, x equals a function of y, right? Two functions of y. And I say rotate around x equals 2. Okay. So this is the problem. Don't want to go there. There we go. Everybody with me? Okay. So I would really quickly, you know, you got to graph them and bullshit, and you're going to go around. What does x equals 2 look like? Yeah, vertical line. All right. 1, 2. So there's my rotation axis. So what would discs require? Integral d what? dy. Is everybody cool with that? Because I'm rotating around an axis parallel to the y-axis. So shells would automatically require dx. Which one of those goes along with the way they've given me the functions I'm working with? Discs, because I have functions of y, yes? And more than likely, well, not necessarily, but more than likely, I can't solve them for y. There's some y cubed or something, whatever. You guys, does that make sense? So, I mean, what tells me how these are going to be set up in terms of just this is just the axis. So I don't even need a bullshit situation. What if I'm rotating around y equals 3? Discs would need what? And shells would need what? So then you look. Can I solve my function for x? Can I solve it for y? You see? Does that make sense? Look, do you understand? I gave you nothing except the rotation axis. And just from that, you know what both of the methods require. So if I cannot solve the functions they gave me, I can't solve them for as a function of y, I'm not going to use this. I can't use this if I can't solve it in terms of y. I can't use shells because it needs dy. It needs everything in it to be functions of y. And this one needs it to be functions of x. Please let that make sense. That is the most fundamental. Now, I still feel like you don't quite, I need that to be something you get. So you're cool with the disks and the shells. Axis of rotation tells me dx or dy.
Yeah, and then
Okay.
you use whatever is.
And whatever functions they gave me, if it's impossible to solve to get x by itself, meaning I get x as a function of y, I can't use shells. I have to use disks.
So when x equals something, that's going to be a function of y.
Yeah,
you
so
use shells.
now it can give us, so like if they gave me x equals y cubed minus 3y plus 1, can you solve that for y easily? No. So therefore, if I had this and I have other shit, I'm going to, more than likely, which method am I going to use? Shells. Because I can't solve that as a function of x, which is what disks would need. So the axis of rotation, that's why every problem we did, I started with integral blank d what? Because that determines everything. Now, that's fundamental. The next level is, sometimes you can solve for x or y. So there's one example we did, I think last time, where it was like y equals natural log of 3x minus 1 or something, I can't remember, right? And if I try to integrate that, I can't. I don't know what the integral of natural log is. Do you? Actually, I do know what it is, but do we know what it is in this class? No. Right? So that's the next level is, if you can solve for x or y, one way might make a function you can integrate, and the other one makes a function you can't. So this is the problem. We solved it for x, and we got e to the y. E is easy. I can integrate e all day. So that's the kind of like the next level of decision. Okay. And that would be if you can solve for x or y. Maybe. What kicks everything off is this method needs integral be something, and the other method is integral be other thing, and then I can start making decisions. Yes? And that only cares about what your axis is. I understand. I haven't decided yet if I'm bad at making decisions. That was a good one, Jeff. Sorry. So, like, if I had rotate around y equals -1, disks would require what? And you can kind of graph it. Here's y equals -1, right? So what would disks require? Integral d what? Dx, because it's parallel to the x-axis. Shells would, of course, require the other thing. So you can write that down immediately. See how I don't care what the functions are? It's just depending on and then I look at the functions and I say, all right, which one? Cross out one of them. Okay, maybe. Because I think I told you that I sucked at this when I first took this class. Because my teacher, I love him to death, God rest his soul, but my guy, he did not explain what the decision points were. Does that make sense? Mm-hmm. Right? He just didn't. And now that I went back and I kind of looked at it again, and all of a sudden I'm like, well, that's the decision points. And that's what students have the most trouble with. Why would I decide to do this? What would make me do this over this, right? Yeah. Cool. Yes.
And then also in the shell formula, when it says 2 pi r h, is that always going to be just a function?
So we for example, if I had a problem like this, right, and I'm rotating around the y-axis or something, then the h would be the function value, because I would draw on a representative rectangle. Now, what if I had this? Where I want to get this rotated. Draw on a representative rectangle. How tall is it? Let's say this is f of x and this is g of x. The height would be f minus g, right? Just to kind of cut to the chase.
And with the radius, if it's further, then
And depending on, so if I was rotating around the y-axis, the radius would just be x. So in shells, the radius is where your representative rectangle is, how far away that is from the axis, right? So in shells, you find your thing you're rotating along the axis that is perpendicular to the rotation. Okay, right? So I think I said that better on that sheet I gave out with all the colors on it. So that's kind of nice. The radius is just going to be either x or y, and the only time it's going to be something different is if my axis of rotation is off a major axis. And they have to add something or subtract something, right? But it's going to be x plus or minus something, y plus or minus something. That's what it's going to be for shells. For disks, it's dependent on the functions now because of the different way we set things up. So in shells, the radius is very straightforward. In disks, it could be a little bit freakier. Inner radius, outer radius. Yes? I don't know if that's helpful, but... So if you haven't really read through that sheet, I would highly recommend you read through it. I tried to capture the idea of what I just said, basically. Yeah. All right.
I'll see you at 2.
What's going on at 2?
We're going to Mount St.
Oh, I
Are
won't.
you going to be there?
You guys are not there at 2. Why would I be there at 2?
Do you only go for like an hour?
No, I'm there today I'll be there from 11:15 till 1.
Okay. Okay. She doesn't get out of class until 1:55, but.
Okay. Thank you. You're welcome.
Yeah. No, okay.
Thank you, Jeff. You're welcome. Anytime.